This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Today we'll be graphing circles. Let's get rolling. The standard form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. This form highlights two key features of our circle that help us draw its graph. The first is the center of the circle, which is located at h, k. In our equation, h and k are the values being subtracted from x and y, and you can think of them as horizontal and vertical shifts from the origin. The second feature is the radius of the circle. R is the value being squared on the right side of our standard equation. Changing r can be thought of as a dilation that causes the circle to grow or shrink. Let's practice finding these two features and using them to draw our graphs. Our first example is the equation x squared plus y squared equals 64. We can start finding the center of our circle by finding the values of h and k. When comparing this equation to our standard form, you may notice it looks like these two parameters are missing. In fact, h and k are just 0, because there is nothing subtracted from our x and y terms. Or you could think of there being no shifts in this equation, so our center is still at the origin 0, 0. Next, let's find the radius. The right side of our standard equation is r squared, and the right side of this equation is 64. So let's rewrite 64 as 8 squared so that it matches. This means that our radius is 8. Note that although we could have written 64 as negative 8 squared, we will always use a positive number because the radius is a distance and so must be positive. Using our radius of 8, we can trace out our circle on the graph. Let's try another one. How can we graph x squared plus y minus 3 squared equals 25? We'll still start by finding the center, and then we'll find the radius. When we look for the values subtracted from x and y, we see that there is nothing subtracted from x, and 3 is subtracted from y. So our center is 0, 3. Let's plot it on our graph. Since the right side of the equation equals r squared, we can take its principal square root to find just r. So our radius is the square root of 25, which is 5. On our graph, we can identify a few points that are exactly 5 units away from our center, like 5, 3, 0, 8, negative 5, 3, and 0, negative 2. And then draw the circle connecting those points. Great job! You're on a roll! This example almost perfectly matches our standard form, except for the fact that there's a value added to y rather than subtracted from it. So it may help to rewrite that plus 5 as minus a negative 5. Now we can clearly see the values subtracting from x and y, and identify our center as 1.5, negative 5, which we'll plot on the graph here. The 16 in our equation is equal to r squared, and so r must be its principal square root, which is 4. Let's use this radius to identify some points on the circle and then draw it. Nice work. Let's try one more together. The last equation is not in standard form, so let's take a moment to rewrite it in that form. Because in standard form the variables are together on the left side and the right side is just a constant, let's start by adding 12x and subtracting 20 on both sides. This is looking better, but standard form only has one x term, whereas this equation has two x terms. We'll have to complete the square in order to write those x terms as a single expression squared. Recall that a perfect square trinomial can be factored like this. So to complete the square, we'll add b over 2 squared to both sides of the equation, where b is the coefficient of our x term. In this case, b is 12, so b over 2 squared equals 36. On both sides of our equation, we'll add 36 and simplify. Now we can rewrite x squared plus 12x plus 36 in factored form as the quantity x plus 6 squared, and see that we've reached standard form. So let's go graph it. Using our standard form, we can see that the center of our circle is at 6, 0. To find our radius, we can rewrite 16 as 4 squared, and see that the radius is 4. We'll extend a radius of length 4 from our center and use it to trace out the circle. And that's our final graph. Awesome job graphing these circles using their centers and radii. Keep practicing and strengthening your skills.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.